Okay, so the remainder of section 3.2 now just talks more about some organization of how to organize these. All right, we're going to first start with what's called binary ionic compounds. These are compounds that just have two different elements in the compound, like barium chloride. We have two different elements. We have a barium and a chlorine. Don't worry the fact that we have two chlorines. We just have two different elements. The difference would be like if I have NaClO3. This is a compound, but notice I have three different elements. This is not a binary ionic. This is what has a polyatomic ion. Okay, this is the difference. I just want to show you the difference. We will talk about these later. Do not worry about this right now. I'm just trying to show you what a binary is versus something different. Okay, compare and contrast. But this is what we're going to be talking about right now. Binary, two different elements. Not I have two atoms, two different elements. Okay, I have three atoms here, but don't worry about the two. We just have two different. That's why it's binary. There's two types, type 1 and type 2. Type 1 is with the main group elements, and we've kind of already talked about how to do that, but we'll talk about how to name them. Okay, then there's type 2, okay, which uses the transition metals. There's something special with the transition metals. Okay, so let's first finish up the type 1, and then we'll talk about type 2. Okay, hold on. I think we already have talked about type 1. I don't think there's any more. Okay, great. We're on the type 2, guys. All right, type 1 was the previous slide. I should look at these slides before I do this. So type 1 are predictable. All right, you know what the charges are. If I give you aluminum and I give you bromine, you know that aluminum has a +3 and bromine has a -1. You just need to look at the periodic table, and then you get AlBr3. Type 2 uses the transition metals. And the transition metals, you're going to find, have more than one charge to it. And it does not correspond to the group number. So do not try to guess the charge based off the group number, because you will not be able to figure it out. There's other things that are going on. If you're interested, I can teach it to you in office hours, but it's not something that we're going to talk about in class. Okay, these are the common ones. They kind of give you the common ones. Notice tin and lead, which are in the main group elements. But remember, these sometimes are called post-transition metals. Okay, because they're after transition metals. They're not transition metals. They're called post-transition metals, and that's because they have more than one charge. Okay, notice iron. Iron and copper are really the two most popular ones between the two. Most compounds have iron and copper. Iron has a 2+ and a 3+. Copper has a plus and a 2+. Okay. Notice there are only three. I'm going to erase this now. Notice there are only three, and this I want you to memorize. There are three elements that only have one charge that are part of the transition metals and the post-transition metals. They are zinc, cadmium, and silver. You have to memorize these. Okay? Zinc and cadmium both have 2+, and silver has a 1+. Now, they did not write in all the other transition metals. That's because they're not common, but they all have two different charges in them. Like scandium, for example, has a +1 and a +3. Okay, it didn't write it in there, but they do. Okay, so again, if you're curious, I can always kind of go over it in class, or I'm sorry, in office hours. Okay, so they didn't write them in, but hold on one second. Okay, so for example, let's say iron 2+, iron 3+. Let's say I combine it with oxygen. All right, this formula would be FeO, right, because they cancel each other out. This formula would be Fe2O3. Okay, they both are iron oxide. This is iron oxide, and this is iron oxide. Okay, but one of them comes from the iron 2+ ion, and the other comes from the iron 3+ charge. So they have different formulas. From the formula, you can figure out which charge we are talking about. And that's how you're going to be able to tell based off of the formula. Okay, this one is the most common one. This one is rust. I forgot my S in there. Rust. Iron 3 is the most common iron. Okay, so this is the type 2. However, it still works the same. Your crisscross applesauce still works the same. Okay, so put this on pause and tell me what these formulas are. All right, hopefully you have wrote the answers. If not, do it right now. These are supposed to be arrows, by the way, guys. I'm looking at that, and you're probably sitting there saying, what in the world did he just draw? It's supposed to be arrows like this. There we go. So iron 3 plus with the Cl minus, the 3 goes down there, the 1 goes down there. You don't need to write the 1, so FeCl3. 2 goes down there, 1 goes down there, FeF2. 4 goes down there, 2 goes down there, PB2O4. Hopefully you're sitting there saying, no Garber, that's not correct. If you are, good job. This is not the lowest common multiple. These need to be divided by the number 2. So the actual answer is PBO2. That should be the correct answer. If you did that, good job. You understand the crisscross applesauce, type 1 and type 2. All right, any questions? Obviously ask me in class or email me. All right, and here's just kind of a list of some of the common ones, okay? You do not have to memorize any of this, so don't think you need to memorize this. They're just kind of showing you some common ones. I show, you know, the iron 2 pluses, there's 10. This isn't even a list I'm going to give you, so don't worry about it. It's just kind of showing you some common ones. Now let's get to naming. Okay, so we've talked about type 1, type 2, writing formulas. It's exactly the same. You do the crisscross applesauce, lowest common multiple. Just in the type 2, in the transition metals, you have more than one possible charge. Okay, so writing formulas is very easy when you're talking about binary ionic compounds. All right, you name the metal first, so whatever the metal is, then you do a prefix followed by "ide." All right, you can see right here, "ide." So chloride, chlor is the prefix. Nitride, oxide, sulfide, sulfide. All right, you just end it in "ide." It's as simple as that. Okay, so if you have a sodium with a sulfur, and you get the formula Na2S. This is called sodium sulfide. You do not put disodium sulfide. People want to do this. Do not do that. I'm purposely writing it and writing it all out. Get rid of that di. Just get it so you don't even see it anymore. Do not do that. So many people do it. Do not do it. Okay, the reason the 2 is there is because you have to balance these out. Okay, you do not have to tell the reader that there's 2 of them. Okay, the reader, if they're reading chemistry, should kind of know chemistry, right? So do not put the dis, tris, all that stuff. There is rules where you use that, and we will talk about them when we get to them. But for ionic compounds, you do not use that. Okay. Okay. All right, so these are the binary compounds. So let's do, I think, are there some practice ones? Here are some common ones: bromide, chloride, fluoride, hydride, iodide, nitride, oxide, sulfide, selenide. I think that's a fun one to say. Selenide is Se2 minus. Phosphide, phosphide is F3 minus. Okay, just some common ones. Okay, naming ions and binary naming. All right, so we've already talked about this. Okay, I feel like I'm kind of repeating in these slides. I'm kind of giving you a head start, but that's fine. You're seeing it at least twice in one video. All right, so you have the lithium ion, you have the sulfide ion come together. The name is lithium sulfide, barium chloride, aluminum oxide. All right, it doesn't matter how many of each you have. This is the name. It's as simple as that. All right, so if you take an, so write the formula for strontium oxide and name this one. What should we do? There we go. All right, put on pause, do the formula here, and do the name for this. All right, welcome back. Strontium oxide. Strontium is a 2+. Oxygen's a 2 minus, so SRO should be your formula. This is called barium selenide. You got it? Good job. You're doing it. No problem. Okay? Now, the transition metals. These are the type 2s. Naming the type 2s are a little different. Because of the fact that there's more than one charge, like let's take the iron for an example. There's a 2 plus and there's an iron 3 plus. We need to tell the reader, and if we combine them with oxygen, I'm cracking myself up because I'm like starting to say one thing and then I say something else. FeO, Fe2O3. We need to tell the reader which iron I'm using in each of these cases. I think we've already talked about that. They are both called iron oxide. They both have iron and they both have oxygen. Okay? Now, I still don't use the monodietri. I still don't do that. I just need to tell the reader which iron I'm using. Am I using the iron 2 plus to get this formula? And I'm using the iron 3 plus to get this formula? That's what I have to put in the name. And I do it by using a Roman numeral. So this one is called iron Roman numeral 2 oxide. This one is iron Roman numeral 3 oxide. Notice they're showing you examples here. So they're taking the cobalt 2 ion and the chloride ion. They're taking the chromium 3 and the oxide and the copper 2 and the nitride. And they're calling it copper 2 nitride because that's the copper. These, the way you figure that out is the reverse crisscross. So 2 there, 3 there. Let's actually do a practice problem real quick. Well, let's do one right here. All right. Actually, no, you know what? Let's erase this and we'll do it right here because that's kind of the flow chart. The flow chart on the next page sometimes are helpful to people, sometimes they're not. It just all depends on what type of people you are. Okay, so if we were to take, let's say, I don't know, let's take, let's just take one of the examples up there. Okay, if I'm trying to figure out what the charge is on this chromium, do a reverse crisscross, like that. So I have a chromium 3 plus. Notice chromium has to be plus because it's your cation, and the 3 came from it because we did the crisscross. Oxygen's a 2 minus. So the chromium that I'm using is a chromium 3 plus. So the name of it is chromium 3 oxide. I'm not sure why I wrote it because the answer is already up here. Okay, so you need to do the reverse crisscross to figure out what charge you have on that ion. Okay, now this doesn't always work perfectly. Let me show you what you also have to be careful of. So this is careful part number 1. Okay, let's take this example. Okay, SN is tin, and obviously oxygen is oxide. So I know the name of it is tin oxide, but tin is one of the post-transition metals that have more than one charge, so I have to figure out what the charge is. So let me do the reverse crisscross, and you're going to see what happens in this case. So tin plus 2, oxygen minus 1. From the formula, it's saying me that this oxygen had a 1 because I'm doing the reverse crisscross. Immediately, you should be saying this is not correct. Why is oxygen minus 1 not correct? Hopefully you said, well, oxygen always has a minus 2 based off of what we learned in the type 1 binaries. And you are correct. Oxygen has to be a minus 2. Do not forget your rules that we've learned. Oxygen is a minus 2. So why is it a minus 1? Because remember, these numbers here are lowest common multiples of each other. So these numbers, even these numbers, they might not be the actual real numbers. They're just the lowest common multiple. Most of the time they are real numbers. The other times they're multiples. So this is actually a 2. This is actually oxygen minus 2. So if you multiply this by this number to get the actual number, you have to multiply this by the same number. So we're doing the opposite of the lowest common multiple. So this is actually a tin 4. Now notice, this makes sense. For one tin, I now have 2 oxygens to balance out. So this is tin 4 oxide. Be very careful of this trick. This is the only, I think, really tricky part of this, is knowing to do this opposite of crisscross, I call it crisscross rather than cross-criss. Instead of crisscross applesauce cross-criss. It's saying it backwards. Um, make sure that you're aware of this so that you can get the correct charge when you're naming these compounds. Okay? So, I'm going the wrong way. So here's kind of a flow chart that kind of helps you along the way. All right, if the compound contains a metal, non-metal, it is ionic. So you have to use the ionic rules. Metal cation has only one possible charge. All right, that's if it's a main group element, so it's an alkali metal or alkaline metal, or it's one of the silvers, cadmium, or zinc, all right, or aluminum or boron, all right, and you name it an ide. If the metal has more than one possible charge, meaning it is one of the transition metals or post-transition metals, like tin and indium and gallium, then you have to make sure you specify the Roman numeral and end it in ide. Okay? So here's some practice problems. Put this on pause and do these problems. Okay, welcome back. So these are examples of all the different types. Okay? So what we're going to do is we're going to go through each individual one, doing the cross-criss method to make sure that we have it correct. So the 2 up here, down there. So this means the calcium 2+ and a nitrogen 3-. Okay, everything is correct. But you know, the thing is I don't have to worry about it in this case because this is one of the main group elements. I don't have to tell the charge. So the name of this is calcium nitride. You only have to do this cross-criss method if you have a transition metal. If you have a transition metal, you do the cross-criss method. Okay? Magnesium and chlorine. All right? This is a main group element, type 1. So this is just as easy as being called magnesium chloride. All right? Here's a copper transition metal. Let me make sure everything is correct. So copper with a +1. Oxygen with a -2. I'm doing the opposite. That is correct. Oxygen does have a -2, so this number is correct. So the answer is copper 1 oxide. All right, zinc and chlorine. Zinc is a transition metal, but it's one of those exceptions that I told you. Remember the exception? Zinc 2+, cadmium 2+, and silver plus. These are the only 3 exceptions of the transition metals that are the exception. So this is just simply called zinc chloride. All right, manganese and oxygen. 2, 3. Let me make sure the oxygen is correct, and I can already tell you it is -2. Manganese does have a -2. So this is as simple as calling it manganese 3 oxide. And then finally, the last one is called lithium phosphide. Phosphide. All right. So, done with section 3. I hope you understand everything. If not, please ask questions when I see you next time.